Hi, welcome back to the Shiko Math Practice Lab, learning through practicing. And we are in the unit Exponential Growth and Decay. And this is our practice number 4. And so this will be our last practice set for the exponential growth and decay type of the problems. And in this practice set, we're going to take a look at how do we calculate the interest, how do we calculate the compounding interest calculations here. Okay, so this is our video number 4. It's a compounding interest calculation here. Okay, so let's go ahead and let's start here. Okay, so for the interest rate, how do we calculate that? Okay, so first, let me write it out, the interest formulas here. Okay, so the interest formula we use is, we call this the A is equal to A0, and this is 1 plus R, and this is N, and this is NT here. Okay, so the first, the R, this R's here, R is the interest rate. And we typical, if we don't say anything, this will be a typical is annual interest, right? Okay, so the annual interest rate. And the N is here. So the next number we need to know is this N. Oops. All right, so the next number we need to know this N. So what is this N? N is the numbers of compounding time per year. In a year. And in our lecture series, if you don't remember what is the number of a compounding time, you can go ahead and go back to our lecture series and review the exponential growth and decay. We did talk about what is the number of compoundings. So if you say compounding quarterly, that means every year you compound 4 times here, okay? Okay, so now the next numbers here we need to know is this T. Okay, so the T, and so the T here is, oops, here, let me get the same color. So the T's here, this is the numbers of years, how many years, right? I put it here. And then the A0s here, the last numbers here, we need to know oops. Okay, so what is that? Let me erase that. Okay, so the A0s here. So what is A0? A0, okay, so these numbers here, this is we call this the principal. It's just how much money I deposit, at the beginning. So this is the compound interest formula if you're compounding in a certain time interval. Or you can see here, this is the A0, ERT. And this is the formula we said instead of compounding like annually, semi-annually, quarterly, this is the formula we say we are compounding continuously. That means every minute, every second, every tenth of the second, we are compounding that, okay? Okay, so now let's see here. Let's solve for this problem here. Let's say if $1,000 is borrowed at 8% interest rate. Remember, if not specifically say this is what, this interest rate is what, this is the annual rate, right? Okay, so now we want to see how much at the end of the 3 years. So the 3 years, that is our years, right? And then now let's see here, if I want to compounding annually, okay? So let's see the compounding annually, how much I'm going to get in the 3 years. So if you're compounding annually, that means every year you only compounding how many times? 1 times, right? So n is equal to 1. So after 3 years, we just give $1,000 times 1 plus. This is 0.08 divided by 1, right? Because you're compounding 1 time. Then how many years? 3 years. All right. So then you can just put it into the formula. You can see this is, you put it into a calculator, is 1259.71. So you initially, you put 1,000, after 3 years, you get about $1,259.71. Okay, so now if I say quarterly, so quarterly, that means every year I have 4 quarters, right? So n is equal to 4. Now in here, this is 1,000, and this is 1 plus. Because 0.08 is the annual rate, now you're compounding quarterly, so divided by 4. Now in here, total 3 years, how many quarters? 12 quarters. So I times power 12, right? Then put it into the calculator is 1268.24. So as you can see, if you compound them more frequently, so what happened? Your amount will go a little bit more, right? So it's like if you compounding once, it's 1259. Here is 1268. Okay, now let's take a look at the third one. They say, how about compound the monthly? If you compound the monthly, the n is equal to 12, right? So here this would be 1,000. Then this is 1 plus 0.08. How many times? You divide by 12, right? So 12, so 3 years, how many months here? 36 here, right? So now you put this into your calculator. Let's see, you get a little bit more than the compounding quarterly, right? So it's 1270.24. Okay, so number 4 is here. If I want to compound weekly, assume the regular year, we have 52 weeks. So now this is 1,000, this is 1 plus 0.08, then this is annual, so you divide it by 52, right? So what is the here? So this will be 52 times how many? Times 3, right? Because the 52, you have 3 years. Okay, so now let's then you put it into your calculator. Let's see here what I got here. Oh, I got is 1271.01 here. Okay, so now for I want to compound the daily. So I assume it's 365 days. So then the A will be 1,000. So this is 1 plus 0.08, 365. And now here, this is 365. How many years? It's 3 years, right? So you times 3. And then now you will get is 1271.22. Okay, now I'm compounding hourly. All right, hourly. So what is my n? N going to be 365 days times what? Times 24, right? And now your money here will be 1,000. So this is 1 plus 0.08. How many times? 365 times 24. Okay, now it's 3 years. So what is your exponent? So it's 365 times 24 times 3. Oh boy, so let's see what we have here is 1271.25. Okay, so the last thing is here. I want to see if I continuously, let me see if I compound it more and more frequently. Like in here, if you take a look, okay, so if you take a look at the amount, right? So like from here to here, right? From like one compounding annually to quarterly, since you make a big jump, it's about $9. Then from quarterly to monthly, you only make about $2. Then from the monthly to weekly, the total amount only increase about $1, right? Then from the weekly to daily, it seems it's only increase 20 cents, right? Then from the daily to hourly, so the increase is kind of like, the even smaller is only you get more than, get 3 cents. So it seems like, when you compound it more and more frequently, they kind of approach, they kind of going to kind of converge to numbers, right? So now let's take a look. If I compounding continuously, that means I'm compounding every seconds, every tenth of the seconds, right? So now I have 1,000, then the RT, R is 0.08 times 3 years, right? So what do you have here? So it's 1271.25. So as you can see here is almost, of course, here I eliminated some like a decimal point. So that's what is this one. It's not going to tell you, when you compound the infinity number of the times, then you're going to get the infinity number of the interest. That's not true. See here, it seems they kind of converge to this number. So even you compounding continuously, you will only get a $1,271.25. Right? So the beginning jump is kind of big, right? So you're compounding 4 times, and then 1 time you're going to increase $9, right? And then it's still increasing, right? But the amount is kind of getting smaller and smaller here. Okay, so it's interesting. Okay, so now let's take a look at number 11th here. So this is our last problem for the compounding interest here. So it asks us how long will it take investment to double in the value if the interest rate is 6%, compounding continuously. All right, so I know this is the compounding continuously, is A, the ERTs, right? So double, that means kind of like the double life. Here we talked before is A0 ERT. So I will see here it's 2 is equal to the ERTs, right? Now I take the natural log here. So the R rate is 0.06 and times t's, right? So what is the t's here? T is 0.06, the natural log of what? Natural log 2 here. Okay, so that is that will be, if you put it into the calculator, this is about 11.55. That means if your interest rate is if your interest is compounding continuously, in order to double that, it might take almost 11 and a half years, right? So 11.5. Okay, so let's say what is the, if I compounding like this way, what is the equivalent annual interest rate here? Okay, so we know that if I compounding here annual rate, so remember the annual rate is the A0 1 plus R over 1, right? And then here is the T, see here. So we say it's equivalent to, that means this one going to be equal to the A0E, the RT, right? So the equal to this is my annual rate. So this is 0.06T. So let's see here. So that means 1 plus R to the T is equal to the E, the 0.06T. And now I can take the t away. And so I will get 1 plus r is equal to the E.06. So what is r's here will be the E.06 minus 1. So if you put it into your calculator, you will get this one. Okay, so you will get this one is equal to 0.0618. So that's about 618%. So this is another very interesting problem here because your interest rate here is 6%, right? So if you compounding continuously is equivalent to, that's why the compounding continuously will have more money. That means equivalent to if you only use the compounding annual interest rate here, right? So that means, in fact, really, the bank could give you is 6.18%. Okay, if you just do 1 year interest rate and compounding annually, all right, so it's 618. So instead of, so they give you 6% and it's compounding continuously. So that's kind of makes sense, right? Because we know if you're compounding more times, you got more money, right? So the 6% continuously is equivalent to if you're only compounding once. Right, so compounding once, that means that they have to give you a higher interest rate. So the interest rate is here is 6.18%. Okay, that's it. And we finished a lot of problems in this unit, the exponential growth and the decay. And we see, that this is very, very interesting applications, right? We can apply it into the natural science, even we can apply to the criminal trial cases to see the dead body temperature. We can apply it in the business area, find the interest rate, and find how much you get back. So it's a very interesting topic. All right, that's it. And hope you have a pretty good understanding of how to apply the exponential growth and decay formulas here. Okay, have a good day. Okay, bye. Talk to you later. Okay.